A ball is moving as a conical pendulum on a 2-meter long string. What is the period of a 5 kilogram ball moving in a 1.6-meter radius? So the first thing you want to do to solve this problem is draw a diagram of what's happening, which is right here. And your knowns are that the mass is 5 kilograms, the radius that the ball is moving in is 1.6. And after you write down all that, you want to draw your free body diagram. And in this problem, you only have the force of tension that the ball is making in the rope and the mass of gravity going down. But I drew the force of X and Y because it's going to be very helpful when you further solve this problem. So the first thing I want to actually know about this problem is what the angle the ball is actually spinning at. And since it gives you the radius and the length of the string, you can just do a opposite off over hypotenuse, take the inverse sine of that, and you'll get 53.3 degrees. So the second step before you set up your net equations, you want to convert ftx and fty into more usable equations. So I wrote ftx equals the force of tension times the sine of the angle that I previously found, and then the force of y equals the force of tension times the cosine of the angle we previously found. So the third step to solve this problem is you want to write out all your net equations. And first off, I start with y because you'll actually get an answer because you know the acceleration is 0. So on the y in my free body diagram, there's two things, which is the force of gravity and the force of tension on the y-axis. So since I just converted the force of tension on the y-axis into ft cosine 53, I put that in there and I subtracted that from the force of gravity and set that all equal to 0, and you should get that the force of tension equals 83. So now that I know the force of tension, I can plug that into my x equation, which on the x-axis there's only the force of tension x. So you plug the 83.3 into sine of 53.3, and you set that up equals to 5 times acceleration, and the 5 is equal to the mass of the ball, which is also given in the equation. And once you set all that up, you'll get that the acceleration equals 13.1. Once you solve for centripetal acceleration, there's only two more easy steps to finish off this problem. And I wrote that the centripetal acceleration, which we solved, is 13.1 equals vt over the radius, which we know is 1.6, and that will give you that vt equals 4.58, and then you have to plug 4.58 into one more final equation, which is the period, which is what we were asked, equals the circumference, which I know is 2 pi times the radius, over what we just got, 4.58, and that will give you that the period equals 2.2.